As you can tell, I changed the title of my presentation because I think I'm clever. The point is, our software might grow in complexity. It might be complex, but how do you keep it from becoming complex AF? Well, so I'm Ethan Stern. I'm a managing partner at Pitfalls Systems. We're a small company based out of Massachusetts, Boston. Some fun things about me, so we can all be friends. I've been writing LabVIEW since 2003. Still like the band 311, and I'm embarrassed to admit it. And I'm learning traditional woodworking, like hand planes and chisels and stuff. And the reason I mention that is because I think I realized toward the end of making this presentation how much my consumption of woodworking instruction has kind of shaped the way I'm trying to deliver information here. There's a zillion YouTube videos on woodworking and how to sharpen your hand planes and how to do this and how to do that. And you know, a lot of the videos that are popular and very interesting are someone who's done a lot of something, opening their toolbox and just showing you some tips and tricks. So I'm going to talk about some generic software engineering concepts, and then I'm going to open the toolbox and I'm going to just show you a bunch of patterns that I've used over the years that I think are clever or interesting or worth talking about. Alright, so you suffer from complexity in your columns, behavioral leaks, list-off sadness, confused semantics, loose APIs, or difficulty maintaining an abstraction. Maybe I can help. So let's think about this for a minute. You know, we have a big monolith, it's a piece of crap. And I'm like, I know actors, so I make like a whole bunch of actors that are all total crap code and are tightly coupled and have weird behaviors. Which one of these is better? It's kind of all crap, right? Like, I don't want to debug the thing on the right any more than I want to debug the thing on the left. So, you know, just because you're using the active framework doesn't mean you're doing it right, and just because I have ideas doesn't mean they're the best ideas. But I'm thinking about this problem all the time, right? Like, I'm abstracting, I'm breaking my code into smaller pieces, but like, am I breaking it into good pieces? Am I breaking it into the right pieces? Abstraction. And you know, this is a maybe slightly more constructive way of thinking about the trash problem. But if it's painful, it's because it's not good. And sorry, but I write code that's not good also. I do notice that I'm starting to get really annoyed by my decisions, and that's why I refactor. And that, like a nuisance, that nagging feeling is sort of my spider sense about technical debt. So let's talk about solid, because everyone loves it. Single responsibility. I've had conversations with people who like understand the acronym SOLID as in they can say the word solid. And conversations about single responsibility have devolved into like, but this VI adds and subtracts, so isn't it breaking single responsibility? No. The heuristic here is one reason to change. Right? So if I'm like, hey Paul, I'm using your event logger, but I don't want to save to a text file on disk, I want to save to a database, right? That persistence is a reason to change. It doesn't mean that there's one VI per class or that there's one primitive per VI. That's insanity, right? So don't get hung up on that. Open, close. You want to write abstractions and software that's open to extension but closed to modification. Say that right? Yes, I did. Meaning, if I have to go back and edit stuff because something else happened, then I'm breaking OCP. And that might be okay because I can't predict everything, but the goal with designing abstractions is to let me write new stuff that doesn't affect the old stuff. List-off. I think this has grown to be the most important solid principle for me. And I think it's one that most people don't understand, or a lot of people. And I've had, again, some weird circular conversations that involve class data, and I'm like, dude, if you're talking about what's in the private data, then we're not talking about list-off, because list-off is about behaviors, right? If I have two things and I can substitute one for the other, but the second one that I substituted in has a subtly different behavior that breaks my caller, like it's returning error codes that I didn't expect, that's a Liskov violation, because now my caller needs to know about all this stuff, and the substitution doesn't work. Interface segregation. I've seen this stated as clients shouldn't be forced to implement interfaces they don't use. Right? I think Steven showed the brittle ancestor class problem where he's talking about adding a pry method, but I shouldn't have this bloated master set of things that my descendants do, and they just kind of cherry pick from that list. That's bad. That's a violation of interface segregation. And even though we don't yet have interfaces in LabVIEW, we can still follow that principle. And dependency inversion, you shouldn't have concrete code depending on other concrete code when you can avoid it. You should have it depend on abstractions. And that way I can decide from high level, semantically, how the bits of my application should interact with each other. But they're not coupled to each other, and they're not dependencies of each other. Right? So these are all important in the things I'm going to talk about. And then we can't talk about what I think is bad without talking about code smells, because some of it is not exactly objectively bad. So I had a different definition of code smells, and I made it ultra generic because it's kind of tough to define. I'm sure everyone here recognizes the feeling of opening some software and saying this needs to be cleaned up. Maybe you don't know solid, or you do know solid and you're not sure which principle it violates. So maybe it's subtle, maybe it's an inconsistency in style, maybe it's clumsy, inefficient, whatever. So we're going to talk about code smells. And then I looked this up because my wife's a librarian, and one of her sticking points is misattributed quotations, like "be the change you want to see in the world" was not actually said by Gandhi. And I thought that this was Archimedes, which it's not. So the dose makes the poison. I'm going to say a lot of things are bad, but please, please, please interpret that contextually. Okay? I'm not saying that polling is always bad, and that if you have an actor that polls, you're an idiot and your code's bad. One of those might be true. All right, so let's talk about actors. The solution to everything. So we're talking about actor code smells here. Right. I have a client, some caller, that depends on motion. Notice that client calls for some motion, and the motion happens, but client's just going to wait because he can't do anything meaningful while it's waiting, and then it does some work, and then it requests another motion and waits some more. Right? So I have this behavior between actors that is effectively synchronous, even though these actors are asynchronous. Maybe a minor code smell. Polling, same thing, client motion. Well, here's another way I could implement two actors or a client depending on the actor doing motion. I move, I check position, I'm polling, I'm hammering the actor's queue with inquiries. That's a code smell. Loaded private data. I know, to be perfectly honest, I did about 2/3 of this. The customer did a third, so shame on him. This is a smell. Like, I know there's something wrong with this code. And I think people are pretty universal in the fact that CLAs love to cluster shame each other, right? Clustersaurus Rex, Godzilla cluster, like, I don't think we talk about that anymore. Quanto loops. I have an actor. This is my, camera method that's actually invoking messages in actor core. Like, I have this TCP/IP thing dangling off the side of it. It's basically an actor without being an actor. If you're going to use actors, then why don't you take advantage of the paradigm and the ability to dynamically launch and relaunch and handle errors and all that stuff. It's Quanto, like it's just kind of sticking out the side. But don't be discouraged because you are what you do. A software developer, this is directly out of Quanto's mouth, is defined by his actions, not his memory. So we can choose a better way. Dependency loops. I just learned that NXG is going to tell us if we create dependency loops in components, which is awesome. If A depends on B, let's say it's classed, can B depend on A? Can it? Yeah, it can. That sucks because I've created a loop, a cyclic dependency, and when we here's a little example. I depend on the actor framework. And what's that done in my auto-populating dependencies folder? But AF-debug, a library I don't want and I don't use. That should go away. Why don't we like dependency loops? Or let's first talk about how do we get these? Mutual direct messaging. Two actors are sending each other messages that belong to each other, right? Those actors are couples. It doesn't matter if they're in separate libraries. In fact, it's worse if they're in separate libraries because now I have two libraries that the compiler is trying to like decide when to stop compiling, I think. I think that's what's happening. Typedefs. Sarah actually talked about how typedefs could be a vector for things coupling to each other in her presentation this morning. And disabled code. Talked about that also. That is such a frustrating vector of disease when I open some code and I'm like, why the heck is this pulling this other thing into memory? And when I finally find it, it's like a diagram disabled that's calling a deprecated method of an API that shouldn't be there. And after Chris Stryker mentioned you should never check in code that has diagram disables in it last year, I thought long and hard about my practices around that, and I started being a lot less inclusive with what I leave in those diagram disables. So who cares? Anyone who opens a project, code develops, or builds an EXE. Load times, like, who's ever loaded customer code? I'm going to say customer code so you don't have to like out yourselves. And it takes like 10 minutes to load the project. Yeah, right. The rest of you have weird, oddly perfect customers. That's a dependency loop problem. When you build an EXE and it like takes 4 times as long, that's a dependency loop problem. All right, so a couple other things that I don't like. Interactive handshakes. Again, we're going for asynchronous actors that are free to do their own work independently without blocking each other. If they're like doing a lot of direct handshake type behaviors, probably not great. Children re-implementing similar message patterns is a smell. You know, that's code duplication, it's additional maintenance, and I bet you a lot of the time it's not necessary. If you have race conditions in an actor-oriented application, have fun. Lots of tight coupled messaging because it leads to dependency cycles. It doesn't mean it's always bad. And leaking semantic requirements. And my example is, and I used to do this all the time when I first started using the actor framework. It was like, I don't know where to put the message sends. My caller can like launch an actor and then send it these 3 messages, but it's got to send this one with high priority. You should launch your actor and it should mostly be able to handle its own business. Because if it doesn't, then your caller needs to know about the behaviors of your actor. And if I want to substitute a different actor and its behaviors are ever so slightly different, that doesn't work anymore. That's a Liskov violation. Okay, so I'm going to stop being negative Nancy for a minute and say things that are good. When you're testing, can you mock? And when I say mock, I actually mean, can you create test doubles, which is a slightly more inclusive category of things, to test your actor? Or is it like, well, I guess I have to put my whole application together and run it and then push the buttons to see if it works. That's how my old actor applications used to work. That's not how they work anymore, and I'm really glad about it. So can you mock it? Can you mock its dependencies? Can you inject them, right? So I can create mocks and wire them into my actor, or my actor does stuff that allows me to actually test its behaviors. Is there abstract ancestry? This might be a lot less important when we have interfaces, but we don't right now. So if I have an actor and I expect to be able to substitute other actors for it, there better be an abstract parent that defines the message set, because when I substitute, the messages shouldn't go away with the actor that I substituted, and they shouldn't be special to the actor. They should be special to the specific type of asynchronous work that I'm doing. Let my concrete actor define the business. Let my abstract actor define the interface to the actor by providing the message set that's always relevant. Is there a clear public API? I've heard people mention different ways of doing this. As far as I understand it, the clear way to define a public API in other languages is to create some kind of grouping that's called public API and put the stuff in there, right? So I can create a virtual folder in my actor or in my class or whatever that says public API, its access scope is public, and that's the stuff that I expect you to call, and nothing else. So here we go. I'm going to show you a by reference class implementation, a better way of writing a driver stack that uses an actor for asynchronousness. That's a word. Abstract messaging with the simple version. Asterisk, everything abstract messaging might also go away, as Stephen pointed out. Defer in action, better message cycles, stateless patterns that are more functional, and a high-level view of designing by contract in an actor and a mutex resource actor, which are kind of like cool computer science-y implementations that are also practical. This is all code that I've actually deployed to projects. So as I touch on things that we Compose Systems has open source packages for, I'm going to just put like a little namespace / package name. So a lot of the code I'm going to talk about is actually open source and available for your use and learning if you're interested. All right, talk about by reference. And again, I'm going to refer back to Sarah's presentation, and she talked about what was it? The path, call path. Path length, thank you. It's not a term that was really a part of my vocabulary until today, and jury's still out on whether it is actually a part of my vocabulary. But this is that kind of cuts to the core of this pattern. It's I don't want or need to go out into an asynchronous thread to do something. I just want to do something. So let's talk about why. Multiple asynchronous callers, right? I need to call the same resource from multiple places. Cool. I can do that with an actor, but I can do that by reference. Are they called short in duration? As in, do I usually just want the thing and I can't really do meaningful work until I get the response? Like, I'm checking a pass-fail flag of a result in a database, right? I don't need to go send an asynchronous request off to a database and then sit there and do some asynchronous work for, I don't know, 1.5 milliseconds, and then come back and see if it passed or failed. I can just wait for it to pass or fail because that's what I need to know to make the next logical decision. And can the callers do anything else? Anything else useful? Well, the call's in progress. So here's how I implement this. And you're going to notice throughout this example, there's a lot of parallelism between the way this is designed or implemented, I suppose, and the way the actor is implemented. So I have a library, and then I have two classes in it that both serve the purpose of this by reference wrapper. Database reference is my reference class. It is my API. And you'll notice that the API's methods are very similar to my abstract class's methods. I call this, I'm going to have to stop calling this an interface class, but in the absence of interfaces, we've been doing this for years. So notice there's duplication between the functionality that the interface class exposes and the functionality that the API allows me to call. That should smell a lot like actor messages, where you have a functionality that the actor actually implements and a message you use to invoke it. It's very much the same thing. And it works kind of like this, where I can inject any type, and I don't mean replace that object on its diagram, I mean wire one in, right? So I can wire in my MySQL or MySQL-like database type object to this VI, and then I have a static link to the reference class here. And then that reference class carries around the active object. All right, so I consider this implementing SRP because I have an API that's responsible for API-like things, and I have an interface class that its job is to define the set of functionalities that the actor can actually do. And this last one, efficient memory use, is not necessarily a reason to choose this pattern over something else. It's just kind of a fun little benefit on the side. So keeping with the theme of this is kind of like actors without the asynchronous thread doing the work, I have a reference to a thing, like an actor's queue. I have some data that I'm feeding into it, and I have this invoker that invokes the concrete functionality of the actual database type that I have, and then it returns the results. So this is a lot like calling a synchronous message do, where I'm sending it off to a different thread to do the thing, and And then I sit there and wait until it gives me a response. Well, why go off into a different thread if you don't need to? Right. This is simple. And because we're engineers, we like decision matrices and crap like that. So I wanted to highlight a couple of things that I consider extreme benefits of this pattern. Right? The type of my reference in this case is, in this example, it was database, right? So I have a database reference that I'm passing around. If I have an actor that is doing database stuff and I pass its actor queue around, what do I know about the actor on the other end of that queue in my code? It's an actor. That's all I know. So it's not typed in a way that actually helps me write safer, better code at edit time. Whereas I have a form of strict typing in the by reference wrapper that makes me guaranteed I can't swap a queue or something stupid like that. What is the API for a by reference implementation? It's the public method set that I define. Whereas with an actor, it's the messages. And maybe you don't actually want all the messages to be public because some of them are for the actor to do its internal work. Execution, right? Caller thread, actor thread. Maybe you need the other one, in which case don't use this pattern. Runtime substitution. It's trivial with this because I can just give myself an API method to like inject a new database type and keep running if I wanted to. I mean, that's probably a weird thing to do, but it's trivial to do. And malleable friendly. The sort of a la carte polymorphism of malleability is awesome. If you're not using it, you probably should be. Asterisk, wait till 2019. And wait till you're working in LabVIEW 2019. It is 2019, by the way. It is, right? Yeah, okay. And then, synchronous, asynchronous, as you'll see next, it can work either way. So you're not locked into asynchronous behavior, synchronous versus and asynchronous. You have some latitude there. All right, so how to build a better driver using an actor. My hypothesis here is, and again, context is everything. I'm not saying you should never have actors talk to actors. That would be silly. But an actor queue and its message set do not have proper API make. I already mentioned the idea of only wanting to expose part of the message set. And also the sort of untypedness of that actor's queue reference, right? Message order matters. That's the whole like startup. I need to send this actor these 3 messages in this order. That's leaking details to the caller. Maybe you have some kind of asynchronous work, and your API could like make a quick decision to say like, oh, you shouldn't even be allowed to do that while the actor's busy with this. And software is expected in different contexts. I mean like heavy reuse. When you really want to design for reuse, you're building a driver. And you know how to use actors, you appreciate the benefits of asynchronous behavior. This is how we've been writing some driver stacks for customers in the field in a way that makes them extremely robust and reusable. So in the implementation, this looks like a library with a few things. All right, so I've got my interface actor. Again, I know I can't call it an interface anymore, but that's my actor. The reference, which is a lot like that by reference API I just showed you, and some cool free stuff, the linear motion test panel, which I just get by designing with this level of abstractness and modularity. Okay, so what are where or why does hardware abstraction get tricky? Where does it fail? Like, I think we've all probably written, like, we tried to abstract an NI DAC, and then the customer was like, oh, I want to use a LabJack or some shitty thing, right? And I go, okay. Like, where does that really break apart? Like, what is the difference between those two things that makes hardware abstraction, I don't know, it's somewhat rhetorical, but if anyone has any ideas and is confident enough to shout them out. I think it's in, yeah.
Well, just because the different devices have different capabilities, and so you design for one, and then that capability doesn't exist on the other device.
And capabilities kind of drives behaviors, right? Like reconnecting to one device might be different because it uses a different, communications port type or something. Right? So for me, like that gets really clunky, and I've stopped thinking about abstracting hardware. don't abstract the box. I abstract the functionality, right? So, like, this box is plastic and red, and this one is plastic and colored like an old Dell computer. Like, I don't think about that in abstraction.
I think my favorite quote on this is, it's better to design for none than design for one. Sorry, it's better to know none than know one. If you don't know everything. I forget exactly how the quote is, but
the message of the quote, if I'm understanding it, is like, if you have one example and you're designing your abstraction around that, it's better to know nothing and design for like actual abstraction. What should my caller know about the behavior of this thing? Right, that is the fundamental question. Yes, we're talking about the actor reference wrapper. It defines the interface. It defines all the messages that any concrete actor must implement. And there's a certain power in that. It implements all the public messages that by reference API might call. Right? So if some other descendant actor needs to define 15 more messages to conduct its internal business, go to town. Those are not even seen or noticed by anything above it. It can include event logging, like whatever. Don't talk to me about event logging, that's boring. Sorry, Paul. Having first-class event logging in your code makes you look like a flippin' genius sometimes. And high-level semantics for all implementations. Some sort of cyclic messaging there. Did I skip a slide? No. So my caller knows this. This is a screenshot of my test suite. It knows, like, if I try to disable while homing, I'm going to get an aborted error, which is an error code I defined, back. Etc. I'm not going to read the test suite to you. But the idea here is that my test suite is testing for the semantics of every possible implementation of linear motion. Right? So my implementations can do whatever they have to do. They're CAN bus, they're serial, they're Ethernet. I can't possibly account for the differences between those things. So I can focus on abstracting and designing around what I know is going to be universal, and make sure that whoever is implementing below that always has this behavior. All right? So the by reference API, this is that wrapper pattern I showed you before, but instead of holding an object, it's holding a reference to the actor. I can use malleability in that to kind of extend my actor message sends and do some data manipulation before I actually send it to the actor if I want to. And you'll see an example of the other things. So this is a really simple call, and you're like, that's dumb. Why wouldn't I just use the actor queue? I've told you already. And sometimes little things can make a big difference. Here, I have my motion reference. I'm unbundling the actor's queue reference, and I'm sending it a high priority abort because that's how I want my API to behave. It doesn't mean I necessarily always want to call abort that way, but when I'm calling it from my API, if I say, yo, motion, abort, that's the behavior I want. So here's another method. I can expose options in my API without cluttering up and messing up the design of my actor. Like, oh, I sent this message, but the message has a flag, and then I kind of invoke it differently inside the actor. Like, no, just do or don't do the thing based on a Boolean flag. That's simplicity. I call this behavioral composition. I don't know if that's nonsense or something someone else invented or what, but I can compose the behaviors of the messages that the public messages of my interface actor, right? So I have these units of functionality, and I can call them in a stacked way or a sequential way to get the desired behavior. And Paul actually pointed this out to me at one point, because I used to operate on the queue reference while the DVR was still valid. But if I close the queue reference, I am guaranteed that the last two things my actor is going to get are the abort and the stop message. And if I'm using an actor queue, I cannot guarantee that without making my actor do some additional stuff. Yeah.
That assumes that no other method is running at the same time that has already done its own dereference of the queue.
Yeah, could an API method have a valid queue reference while I'm calling this?
Unless, is that a single element queue? Like that you're using as a lock other places?
So I think the solution to the problem you're proposing would be that I don't let, for example, here I'm allowing multiple reads, right? If I didn't allow multiple reads, then when I destroy that, I'm guaranteed to have the last one. So that actually might be a reason to change the implementation of this, because I don't have the guarantee that I think I do.
References are tricky.
So Paul points out he doesn't think you can destroy the DVR while something has it open.
Could be wrong, but I'm pretty sure it's
True, but you had it running. You had the enqueuer flank leave the IPE structure, and if it leaves the IPE structure, then you have a problem.
Yes. See, I told you I didn't know everything. All right, so I remember I mentioned a test panel. I was like, yeah, test panels are so cool and great. Like when I've designed this level of abstraction and I have a driver that has a clear API, it's like one button calls one method of the API. It's a piece of cake. I can write any motion implementation for any motor drive type and just call it through here. And I can test the implementation, integration test it. So I can integration test my implementation so easily. I don't have to write anything. I don't have to write a test panel per thing because this guy uses a serial reference and this guy uses a TCP/IP. And if I've gotten here, then I do have actual testability. So the main point of this whole discussion about wrapped actor thing is that simplicity in caller is super important. And this is magical because all kinds of stuff can happen in the actor's thread, and the caller doesn't need to know about it. Right? Caller says move, it gets a promise that motion's going to move because it received the actor message, and then motion does its work. Some dumbass unplugs the cable, and they're like, oh, I should plug that back in. If the drive is able to complete the motion, and then it finishes after automatically reconnecting and tells the caller it's done, I don't have to write error handling for this driver in my application, right? The error handling semantics are so insanely simple, and this is how we use this. If I say move to position 100, and then I fail out of this because it doesn't recover in time, I can just keep telling it to move to position 100 until it gives me a flag that says it's in position. And that's simplicity. I can just keep trying. Just keep trying. That's the only thing the caller can do, because it can't possibly know about all the semantics of the different driver implementations. All right, round trip message. Hopefully I can convince you in a few minutes that abstract messaging is not hard. It doesn't need to be complicated. This is just sort of internal shenanigans. We used to call this abstract messaging, and I was like, well, it's kind of like self-addressed messaging, because you put your queue on it, and you send it back, and it comes back to you. But then I got really confused. I'm a real stickler about terminology, and I can't settle on a name if I don't think it's just perfect. It's self-addressed. That got confusing to me, because when you send it back, it's like, well, you're sending it. What does that mean? Sending it off, or sending it back? Pre-addressed round trip message is what I called it in the last iteration, and we have an open source library that defines only two at the moment active framework message types that I thought were important enough that I'm going to use them in multiple places. Sure, there's more to come, but that's what we have for now. All right, so this huge and complicated thing has the return queue and the priority, right? It's the bare minimum of what a message would need to have to go to some destination. That's the pre-addressed priority. Works like this, right? When I write the return address, it's just an accessor. I'm just constructing the thing with the data it needs to have. When I send it back, I'm just calling active framework on queue. But where does it get real? How do I use that? I can send a message off to something, but how do I do meaningful work? The message I just showed you is good for nothing more than, I suppose, a ping. And if your actors are pinging, that's probably a ghost panel. The notification message is an implementation. It's still abstract because you kind of need to tell the message what to do. But this is one that used to be in the MBA framework. It has I migrated it out to a, I guess, lower level dependency, CS transport, which is a transport abstraction library that abstracts how do you get data from here to there? What if I want to put it in a Boolean text field of a Boolean button? What if I want to put it into a queue? What if I want to put it into an actor as a message? Abstracted. Those all behave the same way to the sender. Okay. So this guy is just extending that private data set with the stuff that notification, right? And this, I said this came from MVA framework, so it's designed to be like a pub sub message. We've got the name of the thing that's being published, its value, and the publication time. We're just following OCP here. We're extending the original message type, the round trip message, by adding in some more concrete data that we're used to needing more work. And this is how it works. A quick, slightly simplified example from the framework. Observer subscribes to the mediator, and then eventually the model calculates and publishes something, and the observer gets it back. That's what this message does. So it completes a round trip, and in this case, the round trip is from the observer to the mediator, and then it sits there, waiting to be fulfilled, and then something happens, and it gets sent back. And it can carry the name and the value because of its private data. And how do you actually ultimately use it? This is a do in a leaf level concrete implementation of notification message. So we've got round trip, notification, concrete. I get the notification, I call the unpack, which is a member of the notification. I'm going to just invoke something. This is just a message due. But it got sent by someone I don't know details about. And I didn't directly access its actor queue. I just sent this off and it came back to me. And Stephen, the reason I was asking about downstream adaptation is because of this really cool thing where I can do a variant of data, and notice I'm not specifying a type. Because the compiler is somehow smart enough to know that it must be, I say that somewhat jokingly, like it's obvious that it has to be a double because I'm wiring it to a double, but it's really cool that I don't have to specify that type. You're like, well, doesn't that seem like a liability? In this case, no, because the class owns this leaf level message. So the class is asking for a data type and then disagreeing with itself about what that type must be, then that's a dumb class, and it should be a runtime error anyway. There's no other way to catch it. Right, so that's kind of cool. All right, deferred action. I already told you something I'm embarrassed about, that I like the Banner 11. So this is a handy pattern. It took me a while to discover it, because probably 100 people already know about it in this room. But when is this useful? When I'm like starting up an actor and it's trying to do some connection event or something at the very beginning of its lifespan, and I just know there's no asynchronous work that actor can do until this succeeds. But I just want to persistently try. But I don't want it to try as fast as it can, because that's not good either. Because it's going to blow up my event log and consume a lot of resources. And this is plain active framework. There's nothing fancy about this. And it's a chance for me to say something nice about time delayed send also. So how does it work? I have a motion session, actor, I launch it, tries to connect, it fails. Uh-oh. This thing can't do anything unless it's connected. Right? So I call time delayed send, but I tell it to send one message, and I tell it to send it later. The power of this is that I'm not blocking the actor's thread while I'm waiting. Right? We launched this other asynchronous message sender that's going to send me the message later when I'm, a second later, 3 seconds later, and I'm not blocking the actor. So if I close out of the application, it doesn't sit there waiting 3 seconds for this actor to time out or something like that. All right, let's talk about message cycles. I already teased you with the fact that I'm going to say mean things about the time delayed send, so here we go. Time delayed send has its use. I'm glad it's there, but I realized it also hurts me a lot, and maybe it's time to move on. Sometimes. So wait until next millisecond multiple. What's the fundamental difference? Because they're basically the same, right? No, they're not. One preserves phase, or tries to, and the other one doesn't. Right? That's a pretty significant difference. All right. Oh, spoil it. So time delay message also preserves phase. Right? I say, send me this actor message every 100 milliseconds. Sometimes you want that. If you're writing a really simple, like, logger chart thing, and you just want to go to your data acquisition and get, 5 hertz data or something, it's like, okay, send me this acquire message every once in a while. That's just the behavior you want, right? You don't want phase drift. Period. That's like a pretty important requirement. You don't want the phase drift. You can handle a little bit of jitter in the execution. If you can't, then you probably shouldn't be using an actor and message to do that. But you don't want phase drift. Sometimes you don't want that behavior, and it's really painful when you realize you don't. So, actor. This is an example of the actor spawning a message sender, right, and telling itself to check if done. It's kind of like self-polling, if you will. But then it starts some asynchronous work and it's busy. So what's happening to that actor while it's busy and that message sender keeps sending?
Queue's filling up.
Queue's filling up, right? That's a pretty obvious problem with this type of message. And actors are supposed to be able to behave this way. So if I don't want phase consistency, I don't want this message type. And is there a way to like tell the notification to stop or like stop it and start it again? Yeah, but that's complexity. That's not the only problem though. There's no guarantee to end. When you have an asynchronous thing sending you instructions, and then like you want to stop that asynchronous thing, you don't really know about its timing. That was the whole point. You like spawn this off into a different loop to be asynchronous. So you don't know if you have messages, redundant messages stacked in your queue. And I experienced this firsthand where it's like, oh, that's what's happening. I'm like stopping it, and once in a blue moon, there's another copy that comes through after I stopped, right? And I have to like check the notifier to see if it's still valid. To say, oh, okay, when I get this message, if my time delayed send notifier is valid, then I know it's a real one. And if it's not valid, then I know it's not real. Or I have to put a flag in actor data, or like have some additional logic that like filters that unwanted message at the end of the cycle. That is the worst kind of complexity. So you can do this. Solve it. I am checking if stopped, and if I'm not stopped, I send myself check if done, but I wait 100 milliseconds. I cannot have that shutdown race condition here. But what's the problem with this?
Block.
It's blocking. Yeah. So my asynchronous actor is not asynchronous in a useful way, because nothing can happen in 100 milliseconds, and it's very easy to say, oh, 100, well, 1,000, sure. Well, if I have 1,000 millisecond wait, why not 3,000? And then your actors are really starting to suck. So this is like a super simple little trick that you could do, but I don't necessarily recommend it. It's simpler. It really is. I mean, there's like not a lot of code here. There's no queue stacking. You can have a known end to the cycle because in the true case there, I can send myself the other message that I always want to invoke at the end, or I could just invoke the method directly on the actor's wire. Right? So I have a clean end, a guaranteed end to that cycle. But it blocks. Stanky, that's the word, right? Okay, so this is the other actor framework message that we've published, and it solves those problems. It's not a trivial problem to solve, so there is some code in here, but it's unit tested and it works great. This is the behavior. So it looks a little bit like sending a time delayed message, but I say, I've got some options here, you guys can read. I say, what message am I cycling? And what message do I want to send at the end? What do I want to make sure is the last message of the cycle that gets executed? And then I have some options just like the time delayed send. Right, so I have all of what I want. I'm going to send myself a thing and then do some work and not block the actor thread. And I don't want to stack the queue. And I always want to guarantee a deterministic, not time-wise, right, but deterministic in terms of knowing what happened at the end of that cycle. So there's no queue stacking, no end, doesn't block, and I have these end of cycle options. So as you noticed from the slide or two earlier, there's also a timeout. So I can say, I want to send myself this message cycle for 10 seconds, right? And if at the end of 10 seconds, I'm still running, I want to do one of those three things. And I also, I didn't actually show this, and I wish I had. There's a notifier reference that comes out of this, just like the time delayed, where I can also programmatically, if I recognize I've reached the end of the cycle, choose from those 3 options and kill the cycle. And the drop message core and everything's implemented, so this is entirely safe from race conditions with respect to always making sure you invoke that last thing. And I do have a test suite that hammers this thing. So, all right, let's talk about functional programming. I'm going to talk more about functional programming later. So, Rich Hickey, the creator and BDFL of Clojure, the functional programming language, he likes to talk about reducing state. I think it's a highly functional concept, right? And how state is complexity and state causes strain, and I totally agree with it. Here, I'm operating on data, and yes, I'm storing some states. I'm not saying like you can't have state. And let me kind of show you why this is more relevant. Because this is the old way I might have done this. The old way. And it's not to say this is not a fine way to do this once in a while. I better talk fast. But we used to put the object, we construct an object, we put it into the class's data, and then we launch it. Right? And then I'm holding on to that type forever. And it makes my cluster grow, and it's really easy for that cluster to grow. When I can do this, I launch it and I send the message with the data in it, and then I don't have to preserve that object. Right? So this is invoking this type of behavior, where I have the object come in and I use it, and I don't hold on to it. I'm reducing the amount of state in my actor. This is the same idea, but a simpler example. Maybe I should have led with this one, where I'm doing some work, and if I fail at that work, I'm going to try again. I consider this to be a highly functional implementation because I'm counting. But I'm not keeping the state on the wire. Right? So I can debug this and say, oh, look, it tried to connect like 20 times in a row. And if you're going to implement this the old-fashioned way, you have to put that state on the wire. It becomes class data. You have to like put in some logic for when you want to clear it and when you want to count. And I've only experienced problems and frustration using those patterns. Whereas this is incredibly simple. All right. And in 3 minutes, we're going to talk about design by contract and mutexing. Fortunately, a guy named Dimitri talked about design by contract last year, and he did a way better job than I would do. So I don't need to talk a lot about the depth. I don't need to get too far into it. The basic idea is, understand the concepts, and it's very entertaining to me to read like blog posts and information about DBC on the internet, because it seems like a lot of people don't really understand what it is. And I think there's even a framework or something that Google uses, where like the design by contract elements of the framework are compiled away at when the application is built. And it's like, that's not how DBC is supposed to work. Like, it's a runtime guarantee of validity when you're executing your code. And Dimitri's example was a spaceship that blew up because it didn't use DBC and it had invalid inputs. So if you're compiling away the logical guarantees, then you probably aren't doing DBC. So I was writing a valve controller, and I had written some older valve control code that had like this crazy like awareness of the master state of the system. It was like really just a big old tangle of wires. And I wanted to confirm that when I switch the state of a valve, it's a safe thing to do, right? There might be some mutually exclusive valve states where I can never set A on while B is on because it's going to smash things into each other. I want to confirm that the state I set is actually valid and safe. I want this to be guaranteed while this code is running at all times. And I wanted to reduce the complexity of that big old tangle. So I wrote this. There's an actor, and its message do basically implements a design by contract pattern where I'm checking a precondition, then I'm actually invoking the method, I'm doing a postcondition check, and just because I want it to be thorough, I'm running a class invariant to make sure the class data is valid. I really didn't need it, but kind of wanted to go all the way. And this is what it looks like. This is a message do, right? Where, yeah, it's kind of a busy message do, but these semantics and rules and guarantees are true for all of my applications that are going to call this driver. I have a precondition that I check. I invoke the method. I evaluate a post condition, and then I do a class invariance. And I only return a modified version of the class if it's all legitimate. It's not pure. It's not a LabVIEW feature. I implemented this in one spot, sort of following the 80-20 principle, I guess. Like, where's the real value here? It's in the setting of the valves. I'm connecting to this controller over a TCP IP port. I don't really care about DBC. But specifically when it comes to arbitrating states and like confirming that things are safe, I wanted the behavior of DBC. So I implemented it in message do. So messages, this is an example of a message implementing what's non-negotiable. It's implementing the semantics that my caller wants a guarantee of. Right? Each valve only cares about the relevant state to its, A might care about B, and D might care about E, F, and G, but they don't have to know everything about each other. My contracts are small, logical blocks that I can check at runtime, and it's testable. I have a test suite that exercises breaking contracts and satisfying contracts. And then last but not least, queuing is not always good, especially when someone's fingers are at stake. I was really motivated to write an awesome linear motion driver after watching a not very thin syringe plunge through my customer's finger in front of my face. I wanted to make sure that when my API is asking for linear motion, only one motion can happen at a time. If my caller is like, hey, move, and it's not done yet, it's like, oh, but also move to this position, and oh, while you're at it, move to this position. The thing's going to be zigzagging all over the place. That's not the behavior I want in a well-controlled caller. I want it to know the thing completed most of the time. And also, there's not any work that the caller can do. Some requests are more equal than others. There's the idea of priority in this implementation. All right, so this is what I wanted. I used a mutex, which is mutual exclusion. Software engineering principle, most of you probably have heard of it. And this is another fancy message do, where I have a sort of synchronous motion request object that comes in this message. This is how I send the message into this actor, and I do a little arbitration, and I say, yes, this synchronous motion request is valid because I'm not busy with one. And this is how I make sure that there's only one synchronous motion request running in this actor. The idea of priority is that if I send an abort, that is considered a synchronous request, and it will take priority over anything that's running. I think you get the idea. But this is a case for designing your actors very purposefully, right? It's not just like, oh, asynchronous is good, everything's an actor. Yeah, again, you notice a pattern here. Shared event logging, shared arbitration, it's testable, everything's consistent to the calling. And when I say, I think back to Darren's presentation a few years ago, the end of brainless LabVIEW programming. I'm sure a lot of people remember that. That one really stuck with me. My point here is that mindless or brainless use of actors causes unnecessary complexity and pain. This is some stuff I've done. I find it useful. I'm not saying actors are bad. I'm not saying the actor framework is bad, except maybe for AF debug. There's no hard and fast. Never ever do this. Don't always do this. We're all professionals and we're all architects, so we got to think for ourselves. So, thank you for listening.